Of the 4 large moons orbiting Jupiter, one has spent decades being treated as the boring one. No volcanoes erupting sulfur into space. No cracked, shifting ice shell. No dramatic underground ocean confirmed by name-brand headlines. Just a dark, heavily battered sphere, more scarred by impacts than any other object in the entire solar system. For years, that's basically all Callisto was known for. A relic. A fossil surface that stopped changing billions of years ago, except 2 separate lines of evidence, one going back 30 years and one confirmed just months ago, suggest we've been underestimating this moon the entire time. Let's start with the basics. Callisto is the outermost of Jupiter's 4 Galilean moons, the large satellites first spotted by Galileo Galilei in 1610. At roughly 4,800 kilometers across, it's nearly the size of the planet Mercury, making it one of the largest moons in the entire solar system. But where its neighbor Io is famous for active volcanoes, and Europa gets endless attention for its suspected ocean, and Ganymede holds the title of largest moon in the solar system, Callisto has historically gotten a fraction of the spotlight. Its surface shows no evidence of tectonic activity, no volcanism, nothing that suggests ongoing geological change. Impact craters simply piled up, one on top of another, for billions of years, with nothing erasing them. That's precisely why scientists nicknamed it, somewhat unkindly, the ugly duckling moon. But in the 1990s, NASA's Galileo spacecraft flew past Callisto 8 separate times, and during those flybys, it picked up something unexpected in its magnetic field data, a telltale signature, the kind you'd expect if there were a layer of electrically conductive material somewhere beneath the surface. Salty liquid water, for instance, conducts electricity extremely well, and Jupiter's own powerful, constantly shifting magnetic field can induce a secondary magnetic response in any nearby conductive material, sort of like a magnet, causing a ripple in a puddle of salt water. If Callisto had a subsurface ocean, this is roughly the kind of signal you'd expect to see. The problem was ruling out a much less exciting explanation. Callisto has its own thin atmosphere and an ionosphere, an electrically charged upper layer, and that ionosphere could theoretically produce a similar magnetic signature all on its own, without any ocean required. For decades, researchers couldn't cleanly separate the two possibilities. The data was suggestive, but not conclusive. That changed with a new analysis published in the journal AGU Advances. A research team went back through all 8 of Galileo's close flybys of Callisto, this time using more advanced statistical techniques than were available in the original studies, and combined that reanalysis with detailed computational models of the moon's ionosphere and interior structure. Their conclusion was striking. Callisto's ionosphere, on its own, cannot account for the full magnetic signature recorded across all 8 flybys. But a subsurface ocean, working in combination with the ionosphere, can. When the team modeled different scenarios to see which one actually fit the data, the version with a hidden ocean fit best. And by a meaningful margin, their best estimate, an ocean at least tens of kilometers thick, likely salty, sitting beneath a solid ice shell that could itself range from tens to hundreds of kilometers deep. Below that ocean, a rocky interior. In other words, Callisto may not be a dead, static hunk of ice and rock after all. It may be an ocean world, quietly hiding liquid water under a surface that hasn't changed enough to give it away. If that holds up, Callisto joins an increasingly crowded club. Europa is already a strong candidate for a subsurface ocean. Ganymede likely has one too. Even Saturn's moon Enceladus is actively spraying its ocean into space through geysers we can watch in real time. The more we look at these icy moons across the outer solar system, the more it seems like liquid water kept warm not by sunlight, but by gravitational tidal forces and radioactive decay, might be one of the more common features out there, rather than a rare exception. Now, here's where the second story comes in. And it's a completely different kind of clue, but it points toward the same broader idea. Jupiter, like Earth, has auroras, spectacular ones, in fact, glowing around its poles. But Jupiter's aurora have a strange extra feature that Earth's don't. Its 4 large Galilean moons each interact electromagnetically with Jupiter's massive magnetosphere, and those interactions create small, distinct auroral footprints, little glowing points tied to each moon's individual position and magnetic behavior. Astronomers had confirmed these footprints for Io, Europa, and Ganymede, using the Hubble Space Telescope. Callisto's, though, remained elusive. Every previous observation only caught faint, inconclusive traces. Part of the challenge was simple overlap. Callisto's auroral footprint kept getting lost inside the much brighter glow of Jupiter's main auroral oval, like trying to spot a candle flame standing right next to a spotlight. Then, in September of 2019, conditions briefly lined up. An unusually dense stream of solar wind slammed into Jupiter's magnetosphere, and just as it does on Earth, when a strong solar storm pushes our own auroras down toward lower latitudes, it pushed Jupiter's auroral oval toward the equator. For a short window, NASA's Juno spacecraft was perfectly positioned to observe all 4 Galilean moons simultaneously, with Jupiter's usually overwhelming aurora shifted just enough out of the way. In that single, precisely timed observation, researchers finally captured a clear, unambiguous detection of Callisto's auroral footprint. Detailed characterization followed across ultraviolet, radio, plasma, and wave measurements, and just as predicted, Callisto's signature matched the pattern seen at its 3 sister moons. The set was finally complete. All 4 Galilean moons, confirmed to interact with Jupiter's magnetosphere in this specific, traceable way. On its own, that's a nice piece of orbital bookkeeping, filling in a gap that had been open for years. But combined with the ocean evidence, it adds another layer to the picture. These auroral footprints are, at their core, a signature of electromagnetic interaction between a moon and the magnetic field surrounding it. The same broad category of physics that lets scientists infer a hidden ocean from magnetic induction data is, in a different form, what produces these glowing footprints in Jupiter's atmosphere. 2 separate techniques, 2 separate spacecraft missions decades apart, both converging on the idea that Callisto is a far more electromagnetically active and possibly far wetter world than its dead, cratered surface would ever suggest. None of this counts as absolute proof just yet, Scientists are appropriately cautious here. The ocean evidence is described as strong, not certain, and confirming it definitively will likely require much closer, more direct measurements than a handful of decades-old flybys can provide. Fortunately, that confirmation may not be far off. NASA's Europa Clipper, already launched and en route, is scheduled to arrive in the Jupiter system in 2030, primarily to study Europa's ocean in detail, but it's expected to gather additional data relevant to Callisto along the way. The European Space Agency's JUICE mission, the Jupiter Icy Moons Explorer, is due to arrive the following year, and unlike Europa Clipper, JUICE is actually planned to orbit Callisto directly at one stage of its mission, offering by far the closest, most sustained look at the moon we've ever had. China's proposed Tianwen-4 mission may add yet another set of eyes to the effort. If Callisto's ocean is confirmed, once these spacecraft arrive, it won't just rewrite this one moon's story. It will add fresh weight to a question that's becoming harder to avoid. With this many ocean worlds turning up around a single planet, is a hidden, tidally warmed ocean actually the exception in our solar system, or is it starting to look like one of the default outcomes? Wherever ice and gravity meet in the right proportions, for now, Callisto remains what it's always been on the surface. Dark, quiet, endlessly cratered, seemingly frozen in time since the earliest days of the solar system. But underneath that unremarkable exterior, the data increasingly suggests something else entirely. A moon that's been hiding an ocean and quietly announcing its presence to any spacecraft patient enough to notice. Beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel. New episodes on space, physics, and the edges of what we understand, with new content going up every day.